Our lesson for today is about geometric sequence. We are going to illustrate a geometric sequence and differentiate geometric sequence from arithmetic sequence. Let us describe the following sequence. From the first sequence, we are multiplying each term by 2 to get the next term. The second sequence is also multiplied not by 2 but negative 2. And for the third sequence, we multiply it by 2/3. What is the difference between arithmetic sequence and geometric sequence? In arithmetic sequence, there is a common difference. From the given example, the common difference is 2 because we are adding 2 to get the next term. While under geometric sequence, there is no common difference, but there is a common ratio. From the given example, the common ratio is 2, since we are multiplying each term by 2 to get the next term. The common ratio, which is R, is obtained by the quotient between the second term over the first term, or the third term over the second term, and so on. From the given example, the common ratio is obtained by dividing 10 by 5 because 10 is the second term and 5 is the first term, and that is equal to 2. Or we may use other pair of terms like the third term, which is 20, divided by the second term, which is 10, and that is also equal to 2. Take note that the common ratio is a non-zero number. Okay, this time, let us find the ratio between the second term over the first term. Here we have 8 divided by 2, that is 4. Next, we have 9 divided by negative 3, negative 3. Next is 1/2 over 1, that is still 1/2. We have negative 10 divided by negative 5, positive 2. K over K minus 1 is actually the common ratio. And for number 6, 3mr divided by 3m, we have r. If the numbers form a geometric sequence, what will be the next term? So we multiply each term by 4. 2 times 4, we have 8 times 4, that is 32. Next we have negative 3, 9. So we multiply each term by negative 3. So this is negative 27. Next, 1 times 1/2 is 1/2 times another 1/2, we have 1/4. So here we multiply it by 2. Negative 5 times 2, negative 10 times 2, negative 20. Okay, next term is 12, 4. The ratio is 4 over 12, and that is 1/3. So the next term will be 4 over 3, or 1 and 1/3. Next, we have the ratio, which is 7 over negative 49, and that is negative 1 over 7. So 7 times negative 1 over 7, that is negative 1. Next, 1/2 divided by 1/4. So the answer is 1/2 times 4 over 1, that is 2. So the next term will be 1/2 times 2, we have 1. Next, a cubed divided by a squared, so the common ratio is a. So the next term will be a cubed times a, a to the fourth. Next, we have k over k minus 1. That is the common ratio. So, k times k over k minus 1. So, that is definitely k squared over k minus 1. And finally, we have 3mr over 3m. The common ratio is r. So, 3mr times r, 3mr squared. Okay, this time let us state whether each of the following sequence is geometric or not. For the first example, this is geometric because we are multiplying each term by 4 to get the next term. 5 times 4 is 20, 20 times 4 is 80, and 80 times 4 is 320. Next, as you can see, the pattern is multiplying each term by negative 2. 5 times negative 2 is negative 10. Negative 10 times negative 2 is 20. 20 times negative 2 is negative 40. So this is geometric. From the given example, each term is obtained by multiplying the previous term by 6/10. So this is also geometric. Next, as you can see for number 4, there is no common ratio but common difference. So each term is obtained by adding 5 from the previous term to get the next term. So 5 plus 5, 10 plus 5, 15 plus 5, 20. So this is not a geometric sequence but an arithmetic sequence. And for number 5, 4, 0, 0, 0. The common ratio is 0, yes, but ratio or the common ratio must be a non-zero number. So we cannot consider this as a geometric sequence. So this is not a geometric sequence. That's all for now. Thank you.